Here goes today's lesson 7.3 in Honors Geometry. Today we're working with interior and exterior angles. So your goal is to look specifically at finding sums of interior angles and sums of exterior angles. All right, well, let's look at a little chart, a pattern. Don't know how many names of the polygons that you know, but let's go ahead and try to name them in order and see how many you can name. Three-sided figure, it's called a triangle. Four-sided figure, quadrilateral, a quadrilateral, a five-sided figure, does not start with an H, starts with a P, and got those two turned around, a pentagon, and six hexagon. Seven is the one that not too many people know. Hepta is the prefix for seven. Many of you, having driven around in cars, oftentimes see octagons. That's octogon. I think it's an O, not an A. Let me reference. Nope, it's an A. I was right initially. Octagon. 9 is a nonagon. Whoops. Getting my letters turned around everywhere. And a 10-sided figure, deca. All right, so know your prefixes there. They will ask you, using those words, what is the sum of interior-exterior angles. All right, one of the things to figure out initially is how many triangles are there inside of that said polygon. Well, in a triangle, there is only one triangle. And we know from a previous problem, previous theorem, that is 180 degrees. And when we can think about that is you take the number of triangles times 180. A quadrilateral, there are two triangles hiding in a quadrilateral. Now I know you could draw two diagonals and create four triangles, but we don't want them to overlap. So non-overlapping, there's two. So each of those triangles has 180 degrees. So the total sum of the interior angles, you can think about a square and a rectangle, are two obvious ones, that will add up to 360. Continuing the problem, pattern, in a pentagon, there's three triangles that are non-overlapping, and times 180 then would give us 540. And for the classic hexagon, the honeycomb, and that would be 720. A heptagon has five triangles, and 5 times 180 is 900 degrees. Octagon, again, 6, so 6 times 180 is 1080. So on and so forth. All right, well, you can clearly see the pattern here that we're just multiplying times another, or adding on another 180, or multiplying by the number of triangles that are in the figure. Okay. So the formula, and the book calls it a theorem, and you can prove this theorem by breaking it into triangles. We're not going to prove it. We're mainly going to do math problems with it. So if you have a polygon, then if n is the number of sides in the polygon, then n minus 2 times 180 degrees gives you the total sum of, we should probably have the word sum there, of the angles. Okay, that is a very important formula. Hopefully you've seen that one before. All right, exterior angles. This one again, like yesterday, I'm going to give you a little informal proof. If we take our exterior angles, notice I've only drawn one exterior angle at each vertex. Yes, so it's not two. I could draw two angles at one, but just taking one per vertex. And if I slide them over here like this and kind of line them up, it doesn't really matter what shape we begin with. You will always see, and this one I have to turn a little bit. And it slides in there nicely. So you can see that they will add up to a full circle. And that brings us then to our second theorem, sum of the exterior angles. And that is a real simple formula. It's always 360. It doesn't matter how many sides you have. The sum is of the angles will be 360. This is a handy shortcut to remember. Finally, the last theorem problem is how many diagonals are there in a polygon? Didn't spell diagonals correctly there, but let's just take a heptagon here and let's draw the diagonals. Now from one vertex we can draw 4. Hopefully you can see that I can't draw to itself. I can't draw to the adjacent vertices, so that knocks out 3 of the vertices. So that would imply that I would need to take the number of sides and take off 3, because again I can't draw to any of those 3. I can only draw to those 4. Now if you go to the next, or let me just pick any random one. Let's take this one here for example, and let me draw the diagonals here now, because in this case we're not drawing for one particular but all of them. Notice I have drawn 3 new ones and 1 overlapping. And if I did that successively for all of them, you would see that I would overlap 1 in each case. You know, if I took this one here, I would overlap that one, and I would overlap that one, and then I would have those 2 new ones, and so on and so forth. So you can see that I'm going to take the number of sides, minus 3, times the number of vertices, and then because we overlap them all, I'm going to divide that by 2. So there's the formula for the number of diagonals. Number of diagonals. Now sometimes you only want this n minus 3 part, because that's going to tell you how many triangles you have. For example, in a heptagon you can draw 4 diagonals from one vertex, and so that tells you you've got 5 triangles. But sometimes they're going to ask you for the total number of diagonals, and that's then how you calculate it. All right, and then we've got 2 little problems here. Number 1, in what polygon is the sum of the exteriors equal to the sum of the measures of the it should say of the interior angles of the polygon. So when do the exteriors and the interiors equal each other? Well, we know the exteriors is 360, and so we look back at our chart and we say, oh yeah, okay, easy cheesy. We see the quadrilateral. Okay, so you don't even need to copy this down. It's kind of like a little problem. But when does the exteriors equal quadrilateral? Okay, I could set this up as an equation and say n minus 2 times 180 equal 360, and I could solve that problem. There's the exterior. Yep. Okay. This next one said, in what polygon is the sum of the measures of the interior equal to twice the sum of the measure of the exteriors? So in this case, it would be n minus 2 times 180. There's the interior times 2 of the exterior. Again, you could look back at the chart, divide by 180. So we end up with, I think this becomes 4 equals n minus 2. And we can see we'd get an answer of 6. And sure enough, looking at that chart, that's what we have. 6 sides is 720. All right, well, hopefully that helps you solve some of the problems. That's the end of the lesson. Good luck on the homework.